Hi, everybody. Today we're going into lesson number 2, complex numbers. We're going to talk about the argand, the modulus, and the conjugate. Start with the argand. What is the argand? Every complex number, as we said, is made out of two parts, the real part and the imaginary part. And what we're trying to do with an argand, we're basically using the conventional x and y axis of the Cartesian display. And we're going to put our complex number on this display. So let's see how we do it. We call the x-axis the real. We take the real part of our complex number and refer to the real axis as the x-axis, and we talk about the imaginary axis as our y-axis. For example, if we take the number 2 plus 3i, this part, the 2, is the real part. Therefore, we go to the x-axis for the number 2. The 3i is the imaginary part, so I'm going to the number 3, which reflects how many i's I have. And that point there, 2, 3, represents the number 2 plus 3i. This would be Z1. Let's look at another example. Maybe my number is minus 1 plus 2i. We call this guy Z2 just for the illustration. So I go to my x minus 1, which is on the left-hand side of the real axis, which is the equivalent to the x-axis. And then I go 2 on my imaginary axis. This point will represent Z2. And we'll just look at one more example. So let's look at the number 3 minus 2i. So I go to my x-axis, which is the real number, which is 3. And my imaginary is minus 2. So I go to minus 2 on the y-axis, which is the imaginary axis. And this number here will represent Z3 if I call this number Z3. That's the modulus. So what's the modulus? Modulus is marked with 2 lines going down, holding the Z. And it's basically calculating the distance between Z and 0, 0. So how do we calculate the modulus? So let's look at an example where our number is 2 plus 3i. So my x-axis is 2. My y-axis is 3. So the x-axis, remember, is the real part, and the y-axis is the imaginary part. And that point there represents 2, 3, which is the equivalent of 2 plus 3i's. The distance between that point and 0, 0. So if you look here at the display, we can see that this triangle here is a right angle triangle. We know that the height of it is 3, because that's the y of the point. We know that the width of it is 2, because that's the x of the point. And we can use Pythagoras to find that length. So we can do 2 squared plus 3 squared and square root it to get the length there, which is square root of 13 in this case. Okay, so this is the modulus of this number. But every time we want to calculate the modulus of complex numbers, we don't actually have to go and draw a triangle and so forth. We already can understand that it's always going to be Pythagoras. So the modulus of Z is going to be always the real part squared plus the imaginary reflected in the number. So for example, if I want to do 2 plus 3i, so it's the square root, the modulus of that is the square root of 2 squared plus 3 squared. What about if I had the number 1 minus 1i, and I want the modulus of that? So again, it's the square root of 1 squared plus 1 squared. And some people say, oh, why didn't you write minus 1 squared? Because minus 1 squared and 1 squared is exactly the same thing. And also, I know that this is a triangle and I'm doing Pythagoras, I'm just writing the positive. I never take I into the formula because I is not the length. I has nothing to do with the length on the graph of the argand. Okay, once we learned about the modulus, let's go to the conjugate. So what is the conjugate? The conjugate is marked with a line on top of Z, or a little wave. And in order to understand the definition, if Z is A plus BI, some complex number, so its conjugate is A, the real part stays exactly the same, but instead of plus BI, we will write minus BI. So this is basically the conjugate. So every number has a conjugate in complex numbers. For example, let's say 2 plus 3i, his conjugate will be 2 minus 3i. What about 5 plus 1i? So his conjugate is going to be 5 minus 1i. What about the number 10 minus 1i? So his conjugate is going to be 10 plus I, and so forth. What about the number I? So the number I has, his real part is 0 because we don't see it. So I'll just write now 0. So the real part stays the same, and the imaginary part just becomes minus I. Okay, so let's look how we can see this and the argand. So let's look again at our example. 2 plus 3i. His conjugate is 2 minus 3i. So when we look at our Argand, this point 2, 3 represents 2 plus 3i. And let's look at the conjugate. So the x is 2 also. And the conjugate will just be down there, and it'll be 2 minus 3. We can also say from here that our distance, which is the modulus, is going to be the same in both cases. So that means from here we can conclude that the modulus of any complex number is the same like the modulus of its conjugate.